staying here until the end. So I'm Christian Annen, I'm from the RWTH Aachen University in Germany, and I'm here to present our paper. The paper is development of an IFC-based converter for BIM integration into augmented reality applications for building construction trades. And very long name, so I try to be short here in the agenda. So I will directly start in the introduction and into the motivation of the research, because the motivation is the skilled trades are not so used to digitalization and building information modeling. So here within this study, just 18% of the companies are using currently BIM, and 76% need stronger digitalization skills. In addition to this, we have no uniform BIM standards for the construction trades, and then we also focusing at the moment more on inspection and verification while using augmented reality. So I came to the research question, how can the information flow be optimized for the BIM-to-field use case in skilled trades? And for this, I give you a quick insight in our workflow. So we have in the first step the BIM-to-Unity workflow, so that the BIM data is readable by a game engine, and afterwards the data will go to the construction site. But in this paper, I'm focusing on IFC-to-Unity. So how can we get our IFC data for our use case in this form we need for the game engine? And so we have the IFC from the planning phase, then we enrich the IFC, and then we extract the 3D data as a GLB, then the semantics as a JSON, and the spatial information as a GeoJSON. And for this, I started with an exploratory literature review, and then I defined core information for this use case based on IFC. And therefore, I studied quite a time the IFC schema, and afterward I implemented these requirements into the IFC-to-Unity converter I'm presenting here. And first of all, by analyzing the IFC schema, I started with a categorization, and there first of all the worker on the construction site needs to know which element do I have to build, and then the schedule, when do I have to build it, and then who is responsible for it, so do I have to build it or someone else, and then where is it located. And to start here with the schedule information, therefore we have IFC task. To this IFC task, or this IFC task, you can specify by IFC task time. This is very good to monitor our status, so the worker on the construction site can say, okay, it's the completion is by 50%, and we can also monitor the times. Then we can assign to this the IFC product, so the element itself, and this element we also can group so that we can locate the element. We can use the IFC spatial structure, and so we have also the opportunity to guide the worker inside the room he needs to go, so by IFC space. And then after all, to the IFC task, we can add now the IFC crew resource, so the trade itself. And this trade can be specified by the labor resource if you have a special role inside your trade. And after all, we can specify this role by an actor, by a person, or by the organization. So we have the opportunity to reach everyone on our construction site directly via the AR device. But in other interesting and I think important points also, how can we bring the model to the site, and what have we considered here? And herefore the IFC have also quite very options like the IFC map conversion. There we can store the data for the spatial placement, and this is also specified by the IFC projected CRS. And the projected CRS is the CRS which is used in the planning phase. And because before I became a researcher, I was a planner, So there are quite many different coordinate reference systems which are used in the planning phase. And there also the information are specified by IFC geometric representation context. And after all, how can we bring our information from IFC to the game engine? And there I looked on 3 different points. The first one is how can we get our coordinates in the GLB data. And this is we need the model near the origin because we want to reduce spatial jitter and visualization problems. But the problem with local coordinates are you can compare them to other plannings. So we use a 2D Helmut transformation to transform these coordinates based on the IFC projected CRS into the coordinates we need for the planning phases. So these are stored in the JSON file. And then finally, we also have the opportunity to enhance interoperability, to use the IFC-to-Unity converter to transform our projected CRS coordinates into VGS 84. And this, the script looks if there is their EPSG code inside the IFC file and then transform it from the source CRS into VGS 84. And here, this is the result. So this is a graphical user interface you can use to enrich your IFC, export GeoJSON, export the JSON for the AR use case. And here you can make settings on the geospatial information, then on the geometric information, then the semantic information. And here I think an interesting point is you can connect a schedule to your IFC, and the information from the schedule are imported directly based on the IFC schema into the IFC. And then finally you can, you have the output and the IFC, the GLB, the JSON, and the GeoJSON. And to validate the process, I first started with an IFC out of a planning phase, so it's not the perfect IFC I needed for my task. And then I use a schedule generator to generate a schedule based on the IFC model. And then I use the IFC-to-Unity converter to enrich the IFC and then export the JSON file with the enriched information. And then I use a Python code to validate the JSON file. Are every information I needed now into the JSON for my AR use? And after all, I've got a report with errors and warnings. And this is the output. I tested 12 different IFC files. And as you see, I checked quite some attributes, and I've got 0 errors, but many warnings. And to tell you the difference, errors are based on this is something not enriched in the IFC file, which I have defined, and warnings are if the IFC file is not in the state I needed it. So because it's not an IFC I prepared for this use case, it's IFC out of the planning phase, and because of this, there are quite some warnings. And now I'm finally at my conclusion. I try to stay in time. And what did we done within this paper? We tried to optimize the data transfer to make the files readable by a game engine. And there we decided to use GLB, JSON, and GeoJSON. Then we defined information requirements in the BIM-to-field use case, but not for supervisors or something like that, with the focus on the skilled workers. So finally, in 2 years, I hope someone can be guided by an AR application based on these findings. And this was defined in IFC 4x3 at 2. And then we tried or we presented an approach how to manage the geodata and to enhance interoperability between BIM, AR on site, and GIS. And that's it. Thank you. And thank you for your time.